Hey, Sahil. How are you?
Doing good.
You're the only one so far. Actually, somebody else just is now coming in, so. Is that you, Saji?
Yes.
So I'm curious, Saji, how come you always show me the cabinet, but you never show me yourself?
Because I usually can't see if I like pop it up. So.
Oh, gotcha. That's fine. Is that is it the cabinet or is it the ceiling?
It's just the ceiling.
Oh, gotcha. All right, today's the 20th, so 5/4. I'm not too far behind. Hey, Richard.
Hi, Ms. Roberts.
How's it going?
Going good.
Yeah. Hard to believe we're at the end.
Yeah, it's going to be a busy week.
Agreed. So what makes it busy for you?
Studying for all the classes.
Understood. Understood. Hey, Jerry.
Hey.
How you doing?
Good. What about you?
I'm doing all right.
That's good.
So, did we finish 5/3? I didn't go look.
Yes.
Yes.
I thought we did. I was just making sure. But we haven't done anything out of 5/4 yet, correct?
No.
Okay. All right. It's 1:02. We've got a lot to do, so I'm going to go ahead and get started. I know that not everybody's here yet, but they will join, and hopefully they will get in on the action. All right. So, starting with, well, let me start with this. Do you guys have any questions from? Oh, my dog is laying on the charging cord. Do you guys have any questions at all from previous sections, 5/1 through 5/3?
No.
Nothing? Okay. All right, that's fine. So then let's go ahead. We'll start with 5/4. The nice thing about starting with the beginning of this particular section, everything is a Math 110 review. So it's actually a pretty easy start to a section. Of course, as all of our sections go, we get a little bit more challenging as we move along. But this one starts out pretty simply. So a couple things, when we're solving equations, by now you guys should know that the word solve means go find the variable, go find x. And so when this says that we should solve either the log equation or the exponential equation, the e equation, so couple things to keep in mind from Math 110. The natural log and an e raised 2, those two are always going to undo each other. You remember that the reason for that is the natural log of, I don't know, the natural log of a, we'll say, is the same thing as log base e of a. So it's just a special way to write a normal log. It's just got a base e to it. So the base e on the log is going to undo the base e on the exponential. So that's one thing to keep in mind, is that they're always going to undo each other. Secondly, one of the things that I always tell my Math 110 students, and I'm actually going to give you some Math 110 rules here in just a moment. But hi.
Oh, I'm sorry.
No, that's okay. Hi, Jonathan.
Hey.
Jonathan, I'm a little curious as to who Lulin is.
Oh, it's my mom's. This is my mom's computer. My computer's dead, and I got little man with me.
Oh,
now.
gotcha.
Yeah. So.
Oh, what a cutie.
Say hey, Roman.
Hi, buddy.
I got him watching his videos.
Yeah. So the first thing I'll do is just share a couple of Math 110 comments with you to remind you of things that we covered in Math 110. So here's some rules that we did in Math 110. Rule number 1 is that e raised to the natural log of x, because of the fact that e's and natural logs undo each other, this is just simply going to equal x. It's kind of like taking the square root of something squared. Square roots and squares, they undo each other. And so it's the same concept where e's and natural logs undo each other. A second rule that we covered in Math 110 is going to be the natural log of an e raised to the x. Again, the two base e's are canceling each other out. So this is just simply also going to equal an x. Okay. One that we've already run into several times is that the natural log of e, just a plain old natural log of e, this is going to equal 1. Okay. And then the next rule, I don't really have a great way to say this one, so I'm just going to write it the way I say it. If bases are equal, then logically the powers have to be equal. So if your bases, if you can already see that your bases are equal, then your powers have to be equal. So these are just some things that we would have covered back in Math 110. I know that that's been a while for you, but nonetheless. All right, so a 110 tip for you. This is not a rule, it's just a tip. And I've already got here that you should isolate the exponential or the logarithm, get it by itself, and I understand that. But one of the tips that I always give out in Math 110, if your unknown is in the power, get the base and power alone. So if your unknown is in the power, get your base and your power alone. At that point, then, you can either get bases alike or log both sides. And again, both of those were things that we would have done regularly in Math 110. Okay. All right, so that kind of gets the Math 110 junk out of the way. So then at this point, let's just dive in and start solving. Okay. So for example number 2, notice that your unknown is in the power. But yeah, it is but my base and my power are already alone. They're already isolated on one side. But what I am going to use is the concept that the base of E and the ln, they're going to cancel each other out. So this is rule here number 1. And so since those base and log cancel each other out, that's just going to leave me with a 3x. So I simplified the left-hand side. I haven't touched the right-hand side. I've just simplified the left side. And then at this point, it turns into a pre-algebra question. So x is equal to 8. Okay. Number 4, on this one, okay, your unknown is in the power, but your base and your power are not alone. Okay, so the first thing that you've got to do is you have to isolate your base and your power. So you're going to divide by 5 on both sides. So that'll be e raised to the x is equal to 36 over 5. Just by dividing a 5 on both sides. And notice that the directions here, or the tip that I gave you, said get the base and power alone. I did that. But then it says at that point, you're either going to make your bases alike or you're going to log both sides. Well, when I look at this, there's no way in the world I can make my bases alike. An E base can never be made into 36/5. You can't make your bases alike. So the only option I have is to log both sides. And since it's the natural log that undoes E's, I'm going to natural log both sides. And as long as you do the same thing on both sides, it's totally legal. So now for the left side, the natural log of e to the x, natural log and an e undo each other. I've just got an x. And on the right side, I have the natural log of 36/5. If you go back to the directions said to solve for x. I've done that. X is alone. I could type this into the calculator. I could type in the natural log of 36/5, and I could get a decimal. I would say you need to follow the directions on WebAssign. Okay, so if your directions say something about approximating, put it in your calculator. If the directions don't say anything about approximating, you can leave the answer as is. Okay, so just pay attention to what it says as far as the directions are concerned. All right, again, my unknown is in the power. Okay, so if my unknown is in the power, we need to get the base and the power alone. All right. So if I get the base and the power alone, I need to start stripping away everything from that base and the power. The e to the x is what needs to be isolated. So the first thing I'm going to move is the 12. So 7 plus 12 is going to end up being a 19. And then after I get that 12 moved, I'll move the 8. So this will end up being a 19/8 is equal to e to the x. Okay, so add 12, divide 8. Again, in a Math 101 class, I would show all that work, but I shouldn't need to in a calc class. Again, this is like the last question. I cannot make my bases alike, so I'm going to log both sides. And so this is going to be x is equal to the natural log of 19/8. Jose, I feel like I'm teaching high school again. Thanks, dude. Number 10. Okay, so again, my unknown is in the power. So somehow I need to get this guy alone on one side. Okay, so what are my options for getting that alone on one side? What should I do?
Multiply by the bottom.
Yeah. So you could call that cross multiplying if you wanted to, Or you could just say you're multiplying the denominator on both sides. So this is going to be 5,000 is equal to 2 times 1 plus e to the 2x. So at least that's going to get rid of the fraction concept. Okay. All right. Somebody tell me what to do next.
Divide by 2.
Okay. So that's going to be 2,500 is equal to 1 plus e to the 2x. And then the last thing?
Subtract the 1.
Yep. So that's going to be what? 24.99 is equal to e to the 2x. So at this point, I've isolated my base and my power. There's no way in the world you can make your bases alike. So we'll just log both sides. And again, I'm choosing a natural log because I already have an e. So we'll natural log both sides. The right side will just be a 2x. Okay, and then the left side is that natural log of 24.99. Still don't have x alone, so the last thing we need to do is divide on both sides by 2. Now, let me make a comment before I leave this question. If you are typing this into the calculator, you would type this one in differently than you would have typed in the last one. Try to show both of them here at the same time. These two are not going to be typed in. Obviously, they're typed in differently because they're different numbers, but I don't mean that. The notation is different. So literally when you are typing the first one into the calculator, let's say that maybe you have one of the older TIs, it would on the screen look like natural log. It opens up a parentheses for you. 19 divide 8, close the parenthesis after that. That's what your calculator would look like if it doesn't do fractions. But the difference is that for the second one, it would be natural log. It would open up a parenthesis for you. You would have 24.99. You got to close that first before dividing the 2. Okay, so on the first one, I'm actually taking the log of the denominator. On the second one, I am not taking the log of the denominator. It's outside of the natural log. All right, so just understand if you are putting it into the calculator, and some of the questions I noticed, it does say to approximate. You will be required to do that. You need to know how to type that in. All right. So this one's a little different. Directions are the same. I'm still supposed to solve for x. Okay. Now, the problem on this one, the only thing that you could possibly do is to use, if you weren't going to use anything with e, the only thing that you could do is use the product rule. The problem with the product rule, it still doesn't let you get x alone. You have to use e. So just like on the last few questions, I logged both sides. On this question, it's not that I want to log both sides. I'm going to, how do I say it? This is the wrong way to say it, but this is what I'm going to say. I'm going to e both sides. Literally what I mean by that is that these two pieces are going to become powers, and my bases are going to be e's. So I'm going to have an e raised to the natural log of 4x is equal to an e raised to a 1. So I'm literally taking the two sides of my equation and making them both into powers. Again, as long as you do the same thing on both sides, that's totally legal. Okay, so now that I've done that, on the left side, an e and a natural log, these guys cancel each other out. So this is just going to be left with a 4x. And on the right side, this is an e, or an e raised to the first power. The direction said to get x alone to solve for x. So divide by 4. So x is equal to e over 4. Again, If your directions say that you should approximate, then type that into your calculator. And because there is an E button right up above your LN button. So you would just type in E, and then you would divide that number by 4. Okay. Any questions? I know I'm plowing right through these, but do you guys have any questions?
Uh-uh.
Okay. All right. So what are your thoughts on this one?
Hmm.
Do we do the same thing we did with the
E
last one?
both sides.
Yeah, let's E both sides. Okay. So if I E both sides, this is going, my E and my natural log are going to undo each other. So I'll have x minus 2 quantity squared is equal to e to the 12th power.
Now would you find the square root of both sides?
So, well, if I ln each side, I'm going to essentially end up back in the same place. So what I'm going to do, yeah, I'm going to take the square root of both sides. Okay. But before you just go and start writing that down, what is another way to write square root?
To the half power?
Yeah, so
Yeah.
that's actually what I'm going to do is I'm going to raise both sides to the half power. You can take the square root. I think it's just a little easier to do the math when you're looking at the fractional powers. So then on the left side, it's pretty easy to see that your powers cancel each other, leaving you with an x minus 2. And on the right side, an e to the 12th to the half becomes what?
E to the 6.
Yes.
6.
Yeah, I don't know if that would have been as obvious if you had written the square root symbol as opposed to the half power. Okay, I don't know. Maybe it would have been as obvious. I don't know. But I think it's personally, I think it's a little more obvious when you have the power version. Add 2 to both sides. So x is equal to e to the 6th power plus 2. And you have now solved for x. Again, if the directions don't say anything about decimals or approximating, this is good for an answer. It's as simple as it's going to get. It's exact. Okay, so now, so all of that was Math 110. Okay, so like I said, we're starting out easy because it's Math 110 concept. That is on your test. It's in your homework. I saw it this weekend when I was writing your test. And so you will have to solve on your test. You will have to solve on your homework. But this is more a calculus concept now. Using derivatives, getting derivatives. Okay. So do you have your formula sheet?
Yes.
So I'm looking at the top half of the formula sheet. And this first formula that I've given you is number 10 on the derivatives, number 10. And the second one that I've given you, the derivative of the natural log, that one's number 9. That one we've dealt with already. Okay. But number 10, we haven't really used yet. Now, in English, number 10, the way that I like to look at this is that this piece here is a copy of the original. I mean, notice it's identical to what you had over there. Okay, so the way that I like to say it is that just copy what you've got first, and then this piece is going to be the derivative of the power. So it's a copy times the derivative of the power. Okay, so that's kind of the English version that I use, and it makes it make a little bit more sense to me. Okay, so if you've got number 36 then, and you're asked to find the derivative, well, the first thing is it's an e raised to some power, so copy it first. So this is going to be e to the negative 2x cubed, just a plain and simple copy. No work done. There is no math whatsoever there. And you're going to take that and you're going to multiply it by the derivative of just the power piece. So what's the derivative of the power?
Negative 6x squared.
Yep, negative 6x squared. The only thing I would do at that point is just rearrange things so that I don't have to use any parentheses. But quite frankly, there's really not any cleanup to do. I would take the second piece and write it first. So that would be -6x squared times e to the -2x cubed. And personally, I think that looks prettier than the first version. Okay. All right. So if I'm asked to find the derivative of this, walk me through this one. So I've got y prime is equal to,
Copy.
all right. So, but what do I do with the 5 out front?
Isn't it
Constant
constant?
multiplier, so leave it as it is.
Yeah, it's a constant multiplier, so you're just going to copy it as you normally would a constant multiplier. And then what?
Then parentheses e to the x squared plus 5.
Yeah, so basically copy the entire thing. So you've got e to the x squared plus 5, and that plus 5 is still in your power. It's just not in the power of the power. Okay,
Find a
so
derivative
of what?
Times
of
2x.
x squared plus 5.
Yeah, which is?
2x.
Okay, so this one I can clean up a little bit more. So if you clean this one up, what do you end up with?
10x equals dang.
Okay. Okay, derivative. What should I do?
Product rule.
Good, product rule. Product rule. All right, so what's the derivative first?
2x.
And then what?
Copy.
Copy the second, so e to the -x. And then what?
First times the derivative of the second.
What's in between? I
Plus.
didn't.
Oh,
Plus.
sorry. Plus.
Okay, you don't have to yell at me. So plus first, x squared times the derivative of the second. Okay, so let's talk through the derivative of the second. How do I write that?
E to the negative power times -1.
Correct. All right, so at this point then, remember that all the way back from chapter 3, factored form is best. So I say let's look at these two terms. Do we have a GCF?
Yes.
E to the -x.
Okay, that is a CF, but it's not a GCF. There's more. You do have an e to the -x.
X.
Yeah, you
X.
also have an x.
Also,
Okay, so then look at the first term. What's left over?
Just the 2.
Just the 2. Now look at the second term. What's left on the second term?
Minus
Negative
x.
Yeah. Okay. All right. Still finding derivative. Thoughts?
the subtraction, right?
Yeah, I totally would do that. So rewrite it first of all. If you try to use the quotient rule on this, it's doable, but it's a pain. Why do the quotient rule when you don't have to? So we've got here the natural log of the top, 1 plus e to the x. Sorry, this is not the derivative. This is just rewriting the original. So if you wrote down that prime like I did, get rid of it. So the natural log of the top minus the natural log of the bottom. Again, I haven't even started in on the derivative yet. Okay, but there's no more cleanup to do, but at least now I don't have to worry about the quotient rule. Now all I have to do is just the derivative of each term. Okay, so for my derivative then, start me out on the derivative of the first term. And we've been here before.
1 over 1 plus e.
Yeah.
To,
Yes, so it's 1 over a copy. So 1 plus e to the x. Okay, times,
E
E to the x.
okay, times e to the x.
times 1.
Technically times 1, yeah, but you don't have to write down the times 1. Okay, so that takes care of the whole entire first term. All right, let's subtract then. Second term, derivative.
Oh, 1 over 1 minus e.
Okay, so 1 over a copy. Times.
Negative e to the x.
Times.
Negative 1.
Negative 1.
Which one is it?
Regular 1.
1.
Why is it a regular one?
Because there's no negative in the power.
There's no negative in the power. Okay. All right, can we clean this up a little bit?
Yes.
Yes. So what are we going to do to clean it up?
Put the
Factor out a negative e to the x, right?
Can you just multiply the fractions first? Or no?
don't they cancel out?
I would just, okay, so let's multiply the two pieces of each fraction together. And then we'll talk about canceling and factoring and all that other kind of stuff. So this is going to be e to the x over 1 plus e to the x. Plus, because I have two negatives there, e to the x over 1 minus e to the x. So my question is there any canceling I can do here?
no.
No.
Common denominator?
You could. Am I also okay with you leaving it as is? Yes. Okay. So if I am going to use a common denominator, I would just have to multiply my two denominators together. Okay. Totally doable. Okay. You guys should be comfortable with that, but there isn't a need for it. Okay. All right. Moving on. All right, talk to me about this one. What are your thoughts?
Quotient
Are you
rule?
gonna rewrite it like the last one?
So,
U equal to the bottom?
Nope.
Oh,
okay, so there are, you threw several things at me. One person said quotient rule. I'll come back and revisit that. One person said, can we rewrite it like I did the last one? The last one I was allowed to rewrite it because I have a rule for rewriting logs. I don't have any logs here. So there is no such thing as just magically turning division into multiplying. That only works when it's the log of division. Okay, and so the last one I was allowed to rewrite it because I had the log of a division problem. And then the third suggestion I heard, it's left me. What was the third suggestion? Somebody said quotient rule. Somebody said to rewrite it.
That U equal to the bottom?
Yeah. And so the reason I can't do that, I only use U substitution in integrals. I've never used U substitution for just derivatives.
Could you take the bottom to the top and make it to the negative first power and do the product?
Oh,
Would that just be nasty?
I think that would be nasty. So don't
What if
be
you
too
separate?
scared. What's that, D'Angelo?
What if you separate?
There is
Could that
no
work?
such thing as a common numerator.
Uh,
So you can't share your numerator with two denominators. You can only share your denominator with two numerators.
ln of both sides?
You could, but then you're going to have implicit differentiation. Remember, the goal here is not to solve. The goal here is to find the derivative. I'm going to go back to the quotient rule. That's the only option. Okay? Don't be afraid of the quotient rule. I know it's a little more challenging, but there's nothing wrong with it. In this case, it's the easiest thing to do. All right, so we've got y prime is equal to, so remind me, what does the quotient rule tell me to do?
Derivative of
Oh, snap.
The derivative of,
the top.
yep, okay, so what is the derivative of the top?
It would be e 2x times 2, right?
Okay, so there's the derivative of the top
Times the bottom.
times the bottom. So that's e to the 2x plus 1.
Minus
The top. Times the derivative of the second.
Of the bottom?
I mean bottom, yeah.
So what's the derivative of the bottom?
Is it e to the 2x?
times 2.
Yeah.
And then it's the bottom squared.
Okay. Now what?
Simplify.
How?
Would you just combine your like factors or whatever?
I'm not sure what you mean by that.
Like, you know, you have that first section. Would you just multiply like the 2 throughout that e to 2x plus 1, and then multiply that 2x by that same thing, or no?
I wouldn't. I wouldn't.
Oh wait,
No.
out that e to the 2x. No.
What did you say, Jose?
I meant the GCF. on the top.
Absolutely.
Not-
Yep. Yeah,
Yeah.
so I've got two terms on the top. Let's pull the GCF out. So take a look at your two terms carefully. What's in my GCF?
2e 2x to the power.
2e to the 2x. Okay. So then in your first term, what's the leftover part?
E 2x plus 1.
Okay. And in your second term, what's left?
e to the 2x.
Close.
Minus e to the 2x.
Yeah, it's a minus e to the 2x.
We get a cancel?
Uh-huh. And I don't usually call that cancel. I usually just call it zeroing out because of the fact that when you subtract two of the same thing, they just become 0. But you're right. Everybody calls that canceling, except for me, I think. And
It's a
so
bit difficult, Mr. Robert.
I'm trying. So then when you take that GCF and you multiply by 1, I don't need that times 1 anymore. So this is going to be 2e to the 2x times 1, which I don't need to write, over e to the 2x plus 1 quantity squared. So that factored form is best. That's coming into play here again. All right. Because factoring is what cleaned it up. Multiplying it together did not clean it up for us. All right, 52.
Product rule.
Product rule. Okay. So we've got y prime is going to equal What's the derivative of the first?
E squared the x
Times. So there's the derivative of the first times the second, tangent double angle,
plus E. Nope, what's the copy of the first?
okay?
Derivative of the second.
Okay, so what is the derivative of tangents?
Secant squared x.
Secant squared. Okay, so secant squared of
2x times
2x
Times 2.
times 2. Chain rule. All right, so as you look at that then, what are your thoughts?
You could
Two
Okay.
2x.
Yep. 2e to the 2x. I didn't hear a 2x power there.
Yes.
So what's left in the first term?
tangent to 2x.
Okay.
Plus
And what's left?
secant squared of 2x.
Yep. And there's no way to make that cleaned up at all. Yeah, not that's worth doing. Secant squared can be turned into 1 plus tangent squared, but I wouldn't have like terms. I still couldn't add the tangents together because one is squared and one is not. So it wouldn't do you a lot of good. All right. So we've been here before. Okay. So if I'm going to find the equation of the tangent line, what has to be my first step?
Find a derivative.
Yeah, I get the derivative. Okay, so f prime of x is equal to?
E, that whole thing. To copy the first one.
Okay, so e to the negative 2x plus x squared power. There's the copy. Times?
Negative 2 plus 2x.
Okay, so this is my generic derivative. So what do I need to do next?
Plug in the 2.
Yeah, so I need f prime of 2. So this will be e to the negative 4 plus 4 times negative 2 plus 4. Okay, so what's the whole first piece going to turn into?
1.
Yeah, so I got a 1 times a 2. So my specific slope then is 2. Okay, what's next?
Y1.
Yep. Minus?
Y1. Oh, to 1. Yes, ma'am.
Is equal to?
2 times x
minus 2.
So you've got 2x minus 4 plus 1.
So y equals 2x minus 3.
Yes.
Oh, snap.
Okay. All right, let's head into number 60. Oh, I'm going to finish today. I'm going to finish with this section. Yay. Same set of directions. Find the equation of the tangent line.
You have to rewrite this one, right?
I would. So how would we rewrite it before we head into the derivative?
log of EX plus e to the negative x minus log of 2.
Okay. It's going to be a lot easier to find the derivative that way. All right, so the derivative of the first piece, the first term. Say it again, I'm sorry.
1 over EX plus the e to the negative x.
Okay. Times.
Times
Derivative of the bottom.
Yep. Which is what?
The EX, e to the x times a 1
Okay.
plus e to the negative x times a negative 1. Right?
Correct.
Yeah.
Okay, what about the derivative of natural log of 2?
Number 2.
Okay, times what?
Would that be 0 over 2?
Yeah. The natural log of 2 is just a constant. Okay, so the derivative of, you could say it's 1 over 2 times the derivative of 2, which is 0. Okay, but you can also say, hey, the natural log of 2, that's just a number. It's a weird number, but it's a number, and the derivative of any constant is 0. Okay, so then let's clean up what we have. So on top, you've got e to the x minus e to the negative x. On bottom, e to the x plus e to the negative x. Now what?
Plug in a 0.
Okay, so plug in my x value of 0. So I'll say that this is the y derivative at 0. It's going to be e to the 0 minus e to the 0 all over e to the 0 plus e to the 0. What does this equal?
0 over 2.
Mm-hmm. Then what? Yes, can I do what?
Wait, never mind. Never mind. I figured it. No, never mind.
We good?
Yes, ma'am.
Okay.
Where'd you get the 2 from?
On bottom, it's a 1 plus 1.
Okay.
All right, so am I finished?
No.
No.
The y minus 0 equals 0 times it. All right.
The y equals 0.
Yeah.
Oh, that's crazy.
What kind of a line is y equals 0?
Horizontal.
It's horizontal. Mm-hmm. Mm-hmm. Yeah. Horizontal one. All right. So why don't you take number 62, because we've got just a couple of minutes. You take 62 and work through this one. All right, you guys ready?
I have a question on that first term.
Yeah.
Is the derivative of the first term e to the x times 1? Because I want to say it's not because there's an x at the front.
So what do you guys think? His question is the derivative of this term e to the x times 1?
Oh, it's product rule, isn't it?
Yeah.
Yes.
Product rule. Yep. Okay, so if it's the product rule, then what are we going to write?
Derivative of the x, which would be 1
1
times e to the x plus
X times e to the
times
x.
e to the x times the 1, which you don't need.
Good. Okay, so that
Minus-
just takes care of the first term only, right?
Yes.
Minus e to the x.
Times the 1.
Mhm.
And then
Which again, we don't need.
And then both those e's cancel out, so you're just left with that middle part.
Yeah, so the first term and the third term are identical to each other and they're being subtracted. So those two can zero each other out. And once they zero each other out, I'm only left with x e to the x. So this is my generic derivative. So now what?
Again, 1.
Okay, so we've got y prime at the x value of 1, which gives,
E.
Decimal.
I would just say it's e.
Okay.
I mean, yes, it is a decimal, but it's a lot easier to write down e than it is to write down the decimal. Okay, so my slope then is e. The equation of my tangent line?
y minus 0 equals e times x minus 1.
And I didn't write down the minus 0 part that you said. So then I would just need to distribute my e to get it into y equals mx plus b form. So that'll be
C.
Yeah, it's weird. This is the one time where that whole factored form is best. We just don't do it because it's not mx plus b form. So honestly, I would probably accept either one of those as an answer, quite frankly. Okay. All right, so that is the entirety of section 4, and that's where I'm supposed to be. Okay, so I was supposed to finish section 4 today. So I am on track. Okay, so I'm just gonna tell you right now, I tried really hard to get videos made for you guys this weekend. It didn't happen. I wrote your test instead. And I'm not lying when I am telling you it took me about 6 hours to write your test. Because I'm having to learn computer code to write some of your questions. I have never taken a day of computer code in my life. So I'm learning a new language. Called computer, and I'm not enjoying that. But anyway, so instead of making your videos, I wrote your tests. But if I need to make a video for section 5, is this the? We've got 2 more sections, right? 5.5 and 5.6. If I remember correctly. Let me ask you this: do you guys have notes for 5.6? Did I provide that for you? For those of you who print notes.
No.
It stops at 5.5.
It stops at 5.5. Okay. I'll try to remember. In fact, I'll write that down as soon as I hang up with you guys. But I will send out 5.6. 5.6 is actually pretty easy. I'm not worried about that one. And trying to think. 5-6 might not actually even be on the on the test. I think it's only on the final exam. Let me check. There is no 5-7. That I know for sure. There's no 5-7. If we get 5-6 done, I'll put it on the test. I'll add a question to the test. If we don't get 5-6 done, I'll put it on the exam. I'm not worried about it. It's a pretty short section. So, so yeah, that means that the only thing left to do on Tuesday and Wednesday is section 5.5. That's really all I'm concerned about. And then that's actually Tuesday, Wednesday, and Thursday because your test is Monday. I am keeping it for Monday. Okay. You guys have any questions for me? Anything at all?
Question.
Yes.
I have a question from 5.2.
Okay.
And the problem is the integral dx over x times parentheses ln x squared raised to the fourth. The dx is actually on top of everything.
Like that?
Yeah.
Is that better? Okay. So, and by the way, guys, it's 1:55. You are welcome to be dismissed because of the fact that I'm not going to hold you past, but I am going to answer this question. So if you want to stay and watch the answer, then you're welcome to do that. Okay, so the first thing, Richard, is I don't love the way it's written. Anytime I have a dx on top, I typically rewrite it and put a 1 on top and put the dx out to the side. And the other thing that I see here, Richard, is that I have 2 denominators. It's a little easier to see those 2 denominators separately as separate fractions. So it's easier for me if I look at this as a 1 over x times a 1 over natural log of x squared whole thing to the 4th times dx.
Mm-hmm.
Okay, so that's just personal, but that's usually what I do. Okay, so my brain just went into 2 different directions. Actually, so option number 1, Richard, well, let me ask you this. What would your thought be? What would you try to do here first?
Find u.
Okay, and what would you use for a u?
ln x squared.
I'm totally good with that. I'm totally good with that, Richard. Another option that you could do, Richard, you remember the power rule, right? You could take that power of 2 and make this into 2 natural log of x whole thing to the 4th. That is also an option. And you could just do the math on the that 2 to the 4th piece, and actually that's a constant multiplier. You could actually throw it out to the front. Okay, but I'm going to go with what you thought of first because that's actually more common. But I just wanted to let you know what you could do. So if u is the natural log of x squared, then du dx, okay, is going to be 1 over a copy times the derivative of that copy. So far, so good, Richard?
Yeah.
Okay. So then I'm seeing here that a pair of x's is going to reduce.
Right.
So I can cancel a pair of x's. And now this is going to be a 2 over an x. But I don't want the 2, so I'm going to send it to the other side. So that'll be a 1/2 du is equal to a 1 over x dx. Okay, we good?
Mhm.
Okay. So now let's go back up to our equation, not our equation, our integral, and let's do some substitution. So the 1 over x dx piece, all of those are going to get replaced with a 1/2 du.
Right.
Okay, so I'll put the 1/2 out in the front and the du out in the back. And then all I have left is this middle guy. And I'm going to say that the inside of this is going to
U.
be, so that's going to be a 1 over u
To the fourth?
power. Yep.
Right.
Okay, so now, typically when we did integral of 1 over u to the 4th, we take that to the top, just makes it easier.
Mhm.
And think of it as a u to the -4th. This is actually not a this is actually not a chapter 5 concept. This is a chapter 4 concept. So the integral of u to the 4th, take your power, add 1, so that'll be a -3, and then multiply by the reciprocal of your new power, which is a -1/3. Does that make sense?
Yes.
Don't forget your plus c, because it's an indefinite integral. Okay, so now I've got -1/6. My u, I'll go ahead and put that back in. My u is the natural log of x squared, and we're raising that to the -3rd power. I don't know that I really care about leaving it like that. You could take that natural log of x squared back down to the bottom, kind of like it was in the original question.
Right.
Okay, so you could make this a -1 over 6 times natural log of x squared, that whole thing cubed. I don't know that I really care one way, or I don't know that one is more simple than the other. Does that help?
Yeah.
Where were you getting stuck?
I was fairly close to that answer, but it was a little different.
Okay.
And then I tried putting it into WebAssign and it wasn't working.
Gotcha.
So I was stuck and I didn't know how to solve it. So I used different resources to check if, like a calculator had a similar answer to mine, and it was completely different. So.
Okay. Okay. All right. Anything else for the few faithful?
Nothing about it.
That's it. All right, guys. I will see you tomorrow.
Okay.
Thanks, Miss Roberts.
No problem. Have a good one, guys. I'll see ya.
Bye, Miss
All right.
Roberts.
Bye, Miss Roberts.
Behave.